To be able to find the domain of a log, what do we have to remember to find the domain of the log? Whatever is inside your parenthesis has to be greater than 0. 3x is greater than -2, so x is greater than -2/3. So the domain, if we put that in interval notation, everything larger, that would be -2/3 to infinity. B, sketching a graph. Remember, we change it to exponential form. So this is 1/2 to the y power equals x. So in our t-chart, y is the exponent, that's where we plug in -1, 0, and 1. What is 1/2 to the -1? 1/2 to the 0. Oops. And 1/2 to the first? It's a half. So if I plot those, 2, -1, 1, 0, and 1/2, 1. Remember, this has a vertical asymptote at the y-axis. Now, for B, we would start by graphing our parent function, which is 3 to the y equals x. Three to the -1, 3 to the 0, 3 to the first, so we have 1/3, -1, 1, 0, 3, 1. This is my parent function. Now, looking back at the original, what would this -1 do to our graph? When you move, you can't just move the points. What else gets shifted over? Asymptote. So you should plot your vertical asymptote at +1. And the graph should look like that. Any questions there? How'd you guys do on those questions? So far, so good? Okay, then, evaluating these. Remember, the answer to a log is an exponent. This is like saying 3 to what power would equal the square root of 3? That's the 1/2 power. Square root is a 1/2. 1/3 to what power equals 27? I know 3 to the third is 27, so if it's 1/3, that would have to flip it. What kind of exponent flips it? Negative, so -3. 2 to what power would equal 1? 3 to what power would equal 81? 10 to what power would be 1/100? -2, we need a negative to flip it. 5 to what power would be 1/5? Right, so these were just finding the exponent. All right, expand. Okay, we see a multiplication between the x and the y, but remember, the 2 and the x are also multiplied. So we need to break this into 3 logs. So we have the log of 2. When things are multiplied, we add. The log of x cubed, what do I do with my cube? Plus the log of y. We can't leave things multiplied or divided in our final answer. So if I look at B, we have the log of x plus 3. I can't break apart addition. Then I'm dividing. If we're dividing, what do we do? Subtract. Log base 6. The cube root is what power? 1/3. So questions on that one? So Next one, condensing. That means putting it back. We know if there's a number in front that turns into an exponent. When I condense, I can only have one log. Because these were subtracted, we would divide, so it'd be x plus 3 over x minus 4 to the third. This one, I bring my 2 up here and here, so we have log base 4 w squared times 3z. You can put the 3 in front, or you don't have to, it doesn't matter. We just need all those terms multiplied, and then divided by the y squared. All right, how did we do on that chunk of problem? So all of these log equations basically boil down to 2 types. The ones where everything has a log and the ones where only some terms have a log. No matter which type, you have to start the same place, condensing any logs that you can. We only want one term on each side. So when I look over here, these logs are added together. How do I condense them? Now, there's a log on one side. Anytime the log is on one side, what's our strategy? So 5 to the third equals x squared minus 20x. 5 to the third is 125, so if you subtract that over, what multiplies to a negative 125 and adds to negative 20?
Negative 25 and 5.
Oops. So if we set those equal to 0, we get 25 and negative 5. And what do we have to remember to do at the end on any problem that starts with a log? Check it. The arguments have to be positive. So 25 minus 20 is good, 25 is good, that's fine. But negative 5 minus 20 is negative. So that one is out, and 25 is the only answer. All right, on this one, there's only a log on one side. If we change it to exponential, we get 4 to the 2x minus 5 equals 64. How would you solve this? Mm-hmm. 64 is 4 to the third. So that means 2x minus 5 is equal to 3. So 2x equals 8 and x is 4. Are those okay? So both of those, we only had a log on one side. Change it to exponential. Now, G has logs on both sides. So we start by combining as much as possible. So on the right, those logs are added, so you multiply them together. That gives us 6x plus 15. Now if there's a log on both sides, what can you do with it?
Cancel the logs.
Mm-hmm. Okay, so if I bring over my 6x, bring over my 3, and divide, we get negative 9. But what do we need to do at the end? Check. Can you put in a negative 9? No, we get a negative argument. So what does that mean? All right. This one, these logs are subtracted. How do you put those together? Mm-hmm. So now, if there's a log on both sides, we can drop it. So if I multiply my 6 over, bring over my 12x, bring over my 2, so we get 20 over 7. If you plug that in, you get positive arguments, so that is our answer. Okay, do we understand how to do log equations? Next up are the exponential equations. So question or slides H and I. Why don't you work those right now? Okay. on these exponential ones, we want to check to see if a common base is an option. Like we saw on the problem on the first page, sometimes that works. If you can't get a common base, what do? Add log. When you do that, the exponent comes down in front. So we get x log 5 equals 2x plus 1 log 3. I have to get all my x's on the same side. So first I have to distribute. So 2x log 3 plus log 3. So bring my x's over. Both of these terms have an x, so what can we do? So to finish, we divide. So we have log 3 over log 5 minus 2 log 3. To check or to get our decimal, we put it in the calculator. Make sure you can do that. And that gives us a decimal of negative 1.8691. On the second one, what should we do first? So then if we add our log, the 0.3x comes down. Over here we get the log of 3/2. So to get x by itself, we're dividing by everything. So we have the log of 3/2 over 0.3 log of 4. And that should give you 0.9749. Are those okay? On if you have an e, what type of log do we usually do? So the x minus 2 comes down. All right, the natural log of e is just 1, so that can cancel. We need all the x's on the same side, so we have to subtract this over. Then they both have an x, so we can factor it out. So to finish, we divide, so we get negative 2 over the natural log of 3 minus 1. Which is negative 20.2814. All right, how did we do on those? Good? All right, I'm going to give you just a couple minutes to wrap up, and then we're going to go over the last chunk. Change of base. What work do I expect you to show? Yeah. So you would write log 11 divided by log 5, which gives you 1.4899. Okay. On K, find the time. So I'm looking for T. I want to triple an investment. So I didn't tell you how much I started or ended with. Give me a starting amount. Then how much would you end with?
30.
Okay, what's my rate? Okay. So 30 equals 10 e to the 0.036 t. Divide the 10. No matter what you picked for your a and your p, you should have this after you divide. So then, because we have an e, we add a natural log. An exponent comes down. We know the natural log of e is 1, so that just cancels off. So then, to get t by itself, we just divide the 0.036. And that gives us 30.5 years. Is that one okay? question was about pH. Find the hydronium ion concentration if the pH is 5.6. So you plug that in for the pH. All right, then what would we have to do? So if we divide the negative, negative 5.6. What's the base of a log? So if I write this in exponential form, we have 10 to the negative 5.6 equals H3O plus. I type that in, I get 2.5 e negative 6 means times 10 to the negative 6th power. All right, how did you do? Good. Are there any other questions? We've got about 5 minutes. Is there anything else you need me to go over? Oh, I'm ready. You're coming 7th or
How many
8th?
questions is it?
I don't know. Like a normal test, 2 pages front and back. I don't remember how many.
Yeah, I'll probably
Go
start it
back
out.
to B so that I can get down to the second part of B.
Oh, yeah.
Can I use the bathroom first?